Let us discuss these higher level data structures in Python: list, tuple, dictionary, and set. This is just an introduction. Details we will see later. So let's start with list. List is a sequence of objects. So for example, here I have a sequence of names, Ram, Shyam, and Mohan, and I can print that list. And you will see that I get a list. It is basically enclosed in square brackets, and the data type is list. List is a class. Similarly, I can have a list of marks. And list can be heterogeneous. That means the different elements of the list can be of different data type. One may have int, string, even a nested list, a boolean as elements of the list. You can index into a list just like you index into arrays in other programming languages. You start with 0. 0 is the first element, so person 0 would be Ram. And Python is interesting, it allows negative indices. -1 means the last one, -2 means the second last, and so on. So persons -1 should give Hari basically. So that's fine. You can get a length of any sequence using this function len. Basically, len applies to list, string, range, tuple, all sequences. When I say sequence, you can understand as list, tuple, string, range. They are all sequences. If we access beyond the valid length, I get an exception named index error, which means the index is out of range. You can slice a list, or rather any sequence you can slice. And when you slice, you simply say that give me a subsequence starting at this index and stopping at this index. Of course, the stop is excluded. You can give a step size also. You can say start at start index, stop at just before stop index, and have a step size this one step. So let's see an example. Let's say we are slicing this list and we say start at index 0, that means Ram, stop at index 2, which is Mohan, but stop is excluded, so I should get an output Ram and Shyam. So that's what I get. And I might say something like this: start at index 0, which is Ram, stop at index 3, which is Hari, and have the step size of 2, that means Ram, and then +2 Mohan, and +2 I go out of the list, so it stops there. So I should get Ram and Mohan. That's what I get. Lists are mutable. Mutable means that you can modify the content. There are some things which are immutable. Strings are immutable, tuples are immutable. You cannot change their content. List you can change. For example, I can change the value of person 0 to Shri Ram, and that change will reflect. It is a mutable thing. You can modify it. You can concatenate two lists using the plus operator. In fact, you can concatenate any sequence using plus operator: list, tuple, string, range, all of them. So that just concatenates the two lists. You can repeat a list a number of times. So for example, you may say repeat this 1, 2, 3 three times. So you can say *3 and it will be repeated 3 times. Again, this concatenation, repetition, indexing, slicing works the same way on all sequences: list, tuple, string, range. Iterating through a list, that means you want to go through each element of the list. So you can say for element in, then any sequence: list, tuple, range, string, even dictionary or set for that matter, any iterable. For loop is like for element in any iterable on which you can iterate, and then you can do some processing. So I can say for I in L1 print I star I, means print the square of each element, and that's what I get. There are many more things in list we will see in subsequent videos, but if we want to have a glance, we can do help list, and we see that you can append elements, you can clear out the whole list, you can make a copy of the list, which is a shallow copy. When a list contains nested objects, it doesn't contain the object as is, it contains a reference of that object. So when you copy, then the copy also refers to the same nested object. We will look at this concept more in subsequent videos, but understand it's a shallow copy, not a deep copy. You can count occurrences of a value, you can extend with some other iterable, you can search for a value, You can add and remove either at the end or even in the middle or beginning. You can sort, etc. There are a lot many things. Let's discuss tuples a bit. Tuples are very similar to lists except that they are immutable. They cannot be modified. Syntactically, instead of the square bracket, you use the round bracket. So let's say we create this person's tuple, Mark's tuple. They are very similar to what we saw in the list above. They can also be heterogeneous just like lists. So you can mix data types, you can have string, integer, nested list, nested tuple, nested dictionary, boolean, all mixed up in one tuple. So data structures can nest. You can have list of tuple, tuple of list, tuple of dictionaries, a dictionary having something mapping to tuple, etc. etc. Indexing is the same way. Just as we saw for list, it is absolutely identical. You can have negative indices, you can have a length. If you go beyond the length, an exception is raised, just in the same way as we saw for list. Slicing absolutely identical as list. Tuples are immutable. If you try to modify an item, you will face an exception. So I get an exception that tuple object does not support item assignment because it is immutable. Similar exception you will face if you try to modify content of a string, because string is also immutable. Concatenation works the same way as list. Plus means concatenation, and plus concatenates any sequence. So that works the same way. Repetition works the same way. Star means repeat. Iterating is absolutely the same way as other sequences like list. What more methods do you have in tuple? In tuple, you find that there is not much. In list, we had a lot of things because list was a mutable data structure. You can add things, you can remove things, but tuple is like a fixed read-only kind of thing. So you can count how many times a value is occurring, or you can look for a value. Not many methods exist, right? Tuples are very useful when you want to have some read-only kind of data. Let's say you are reading something from a comma separated value CSV file, and you want to process it, you want to do some data analytics on it, but you don't want to modify it. So you can use tuples in this case. Let's go through dictionaries. What are dictionaries? Dictionaries basically map keys to values. They are key to value mapping. Okay. So syntactically, they look something like this. You have a, within curly braces, set of key value pairs. This key is mapped to this value, this key is mapped to this value. So for example, you can have a telephone directory kind of dictionary. Tom has this extension 1234 and Harry has this extension 6745. And if you create such a dictionary, so this is how a dictionary looks like. Curly braces, key colon value, key colon value. And the type is dict. Accessing an element, they are like associative arrays in which the index can be some non-integer also. It can be any data type because this dictionary mapped string to telephone extension. So I will index it with a string and I can get the extension of Tom just like that. If I have to modify the extension, I can modify it also. So that's modified. If I have to add a new element, then I can use a non-existing key and I can say equate it to 1, 2, 3, 4. So I will be adding this entry RAM mapped to 1, 2, 3, 4 by this step. So you can see that this new item is added into the dictionary. A key cannot repeat. If I give the same key 2 times, then I will not have 2 values for the key. The last value will persist. So if I print x is 3, the previous value is overwritten. So a key cannot repeat. Keys can be heterogeneous. For example, consider this dictionary. It is mapping this integer 1 to true, mapping this string to a tuple, mapping this tuple to a string. Of course, design-wise, it may be an obscure design. Unless you have a valid reason, you can keep things uniform that the key is of this data type and the mapped value is of this data type. But in general, you have the flexibility. You can have the keys of different data types. One thing to note in map and even in set, the key has to be of immutable data type only. I cannot use a list as a key. because list is mutable. If I run this cell, it gives an error. It says unhashable type. The internal reason is that it uses hash table for storing the data and it needs to compute a hash on the key. So the key should be a constant thing. It should not be a mutable thing. It just changes over time. That doesn't work. You can loop through a dictionary. When you loop through a dictionary, you have two things, key and value. So what do you loop through? Are you looping over the keys or are you looping through the values or both? So you can have different variants. If you loop, by default, you loop over the keys. For I in name to extension, I happen to print the keys. If you want the values, then you can use this method values. You will get the values. If you want both, then there is something called items which returns items. And what is an item? Item is a pair. Item is a key value pair, or it is a key value tuple. If this items is returning tuples, you can catch it into two variables, k comma v, and k will take the key and v will take the value. So you can iterate in this manner also using dot items so that you get both. And then of course there are more in dictionary. You can clear out the entire dictionary. You can make a shallow copy. You can get value of a key. For iterating, you can use items or keys or values. You can remove certain things. You can add more things. Let's get introduced to set. Basically, again, it uses curly braces, but we only have value. Internally, it uses data structures very similar to map. Let's say we create this person set. A value in a set cannot repeat. So if I give Ram 2 times, I will still see it only one time. Sets can be heterogeneous. You can have a set of numbers, strings, tuples mixed all together. Again, set can only have immutable objects. If you try to put a list in a set, you will face a exception. Because again, it uses hashing internally and you need to have only immutable constant data. Because list is an unhashable type, you cannot do that. Set supports all those operations which we studied in school, like intersection, union, difference, symmetric difference, is it superset, is it subset, all that. Some are demonstrated here. You can take a union of two sets, you can take an intersection of two sets. Iterating, when you iterate, you get the individual elements. So that's very much similar to other data structures we saw. What else we have in set? You can add things to a set, you can clear out the set. Again, a shallow copy, difference a minus b, and intersection, union, popping, removing. That covers a broad introduction to these high-level data structures, list, tuple, dictionary, set. We will see more details in subsequent videos.